using the graph of the first derivative to make conclusions about the original function, but we're going to do a second derivative analysis, right? So we're doing a second derivative analysis, but we're given the graph of the first derivative. So it's kind of confusing. All right, so let's look at this. So when we look at the first derivative, what we want to do is determine when is the second derivative. So when I make this sine chart over here, this is a sine chart of the second derivative, okay? And we're not doing the whole negative infinity, positive thing. So this is ending at -3. So we're going to say it ends at -3, all right? And it's going to end at 1, 2, 3, 4. It ends at 4. Okay, so we're not doing negative infinity, positive infinity stuff. We're going to actually use the numbers given to us. All right. Yeah, even the other ones. All right. So here, what we're looking for in the first derivatives is when it hits a peak or a valley. All right. So here, there's a peak at -1, and about 0, and a peak at 1. Okay. So we're looking at high points and low points. High point. This is not a low point because it keeps going that way. So what's happening to that derivative between -3 and -1? Well, it's going up. It is increasing. So we say that. So the second derivative is positive then. Between -1 and 0, it's decreasing. So the second derivative is negative. And between 0 and 1, it's increasing. So the second derivative is positive. And then from 1 all the way up to 4, it's decreasing the whole time. So we say the second derivative is negative. So what does that mean? So it's concave up where the second derivative is positive. So it's concave up from -3 to -1 and from 0 to 1. It's concave down where it's negative, so it's -1 to 0 and 1 to 4. What are the points of inflection? So here we can only give the x values. Points of inflection are -1, 0, and 1. That's it. All right, continuing, g prime of x. All right, we're going to make a sine chart of the second derivative. And we're starting at 0 and ending at 9. Okay, so we're looking for peaks and valleys. So it hits a low point here. And you can argue it's at 2 or is it 3, okay? But what's it doing from 0 to 2? It's going down. And from 2 to 3, nothing's happening. That's a 0, okay? And then it's increasing from 3 all the way up to 6. So it's increasing there. And it's decreasing from 6 to 8, and then it's 0 there. So it's concave up from 0 to 2. No, I'm sorry, concave up from 3 to 6. Concave down from 0 to 2, and 6 to 8. Yes, that's a 6. That's not a 0. And what are the points of inflection? So here's a weird part. You can really say there's a point of inflection x equals 6, but what would you call it at 8? Because it's going from negative to 0. It doesn't really change signs, and we're going to just say it's not. Okay. By the way, this is a really weird graph. All right, so that's it. So we're going to say there's a point of inflection at x equals 6, and we're going to ignore the other weird spots, this 2 and 3 thing. That is not a point of inflection. That's like a line of inflection. So I believe. I don't know. I asked the professor the other day, a couple years ago, and I forgot what his answer was. I think the point of inflection is when. Well, I can't answer that question. All right. Okay, so here, this one, make a sine chart of the second derivative, and we get from 0 to 6, 0 to 6. What do we got here? So it's increasing from 0 to 1, it's positive. It's flat from 1 to 2, and it's decreasing from 2 to 3. It's flat from 3 to 5, and it's decreasing after that. It is nasty. So it's concave up from 0 to 1, concave down from 2 to 3, and 5 to 6. And then it's questionable whether there are points of inflection. You could argue there's a point of inflection at 3 or 5, but we're not going there. All right. So here, this is going from, we're going to say -5 to 3. -5 to 3. So -5 to 3. And we we got a peak here at -2, and we have a valley here at 1. So it is increasing from -5 to -2. It's decreasing from -2 to 1. It's increasing from 1 to 3. So it's concave up from -5 to -2 and 1 to 3. Concave down from -2 to 1. And the points of inflection. So this is a straightforward question. -2 and 1. Okay. And one more. So we have it. We're going to go -1, 2, 3, 4. We're going to go up to -4. And 1, 2, we'll say up to 3. So we have a valley here at -2.5. And we have a peak there at -1. Valley there at 1. And that's it. So it's decreasing from -4 to -2.5. And then -2.5 to 1. Or -1, it's increasing. Then it's decreasing there. It's increasing after that. So we have concave up at -2.5 to -1 and 1 to 3. Concave down from -4 to -2.5 and -1 to 1. Points of inflection are at -2.5, -1, and 1. And that's it. I'm not going to do any more tonight. Good night.